Okay guys, so after having a brief knowledge of your crystal field theory, now we are going to come across with a new concept within the coordination chemistry, which is called as isomerism in complexes. We came to know that isomers means what? They are the two or more compounds having the same molecular formula, but they will have some different mode of the attachment. But with respect to the complexes, how can you define the isomers means? They are the two or more complexes which have the same molecular formula, but they differ in the arrangement of the atoms. That is, another arrangement of your ligands is called as an isomers, and the phenomenon which is called as your isomerism. So basically, this isomerism has been briefly classified into two types. One is called as that of your structural isomerism, and the second one is called as that of your stereoisomerism. So first of all, let us deal with this structural isomer. They have been further classified. The first one, let us go, which is called as ionization isomerism. Yes. So instead of giving the definition, of course you could see in my notes itself, but I would like to give it you an example. So if I take an example of CONH3 5 Br SO4, this is one complex. Same complex with slight change I am doing with my counter ion CONH3 5 SO4 Br. So we know that whenever you're choosing a complex and you're dissolving it in the water, of course the counter ion will be one ion, and overall this complex within this square bracket will be a one ion. So on dissolving this one, what happens? This will be giving you as CONH3 5 Br 2 plus, yes, plus SO4 2 minus. But this complex will be giving you as what? CONH3 5 SO4 minus, SO4 plus Br minus. You can just see that. So whenever these complexes are dissolved in water, we are getting the respective ions. In case if I am treating both these complexes in water with respect to the barium chloride solution, of course what happens, my barium chloride will react with my first complex because it is having a sulfate giving you the white precipitate of your barium sulfate. Whereas when I am using my Ag silver nitrate solution for time being, so on adding my silver nitrate solution to both the complexes in the solution, what happens? The second complex reacts with it to give you the yellow solution of AgBr. So now we will define it. What do you mean by ionization isomerism? So you can just see that two or more complexes having the same molecular formula. The molecular formula is same. Both are containing similar atoms and the molecules. But they differ in the ions produced after dissolution. So complexes are having the same molecular formula. But when they are dissolved in water, what happens? In the first case, I got my sulfate as an ion. And in the second case, I got my bromide as an ion. So this type of a complexes are called as what? Ionization complexes, or isomerism is called as what? Ionization isomerism. Is that clear? The second important part now we are going to see with respect to the structural isomerism, another type which is called as linkage isomerism. Linkage isomerism. So here also two or more complexes will be having the same molecular formula, but they were differing in the mode of the attachment of the ligands. That is, how is your ligand is attached to your central metal atom or the ion. So for this one, you have to remember that linkage isomers is mainly exhibited by that of your ambidentate ligands. If you are remembering, we know that ambivalent ligands means what? They are having two donor atoms, but at a time they can only donate through only one donor atom. Let me take an example over here. That is, you are given as CO, NH3, 5, NO2 and a Cl2. Yes. And in another case, the same complexes can also be written as CO, NH3, 5, ONO, Cl2. You could see that here whatever the nitro part you have taken, it is acting as what? An ambidentate ligand, which is in which both nitrogen and oxygen are the donor atoms. But in the first example, if you are looking, the mode of the attachment of the ligand is to the nitrogen atom. Whereas in the second example, you could just notice that the mode of the attachment is to the oxygen atom. So linkage isomers means what? Two or more complexes are having the same molecular formula, but they are differing in the mode of the attachment of the ligands to your central metal atom or the ion. If, for example, if I'm going to write it, so this is for the mode of the attachment. You could just see that the nitrogen is attaching your central metal atom or the ion. But in the second case, when I am writing as CO, you just see that the mode of the attachment is through the oxygen atom because that is donating it. Alpha. And here you will be having your ammonia groups. Cl2. But to understand, so here what is happening, the mode of the attachment is through the nitrogen atom of your nitro group, whereas here it is through the oxygen atom of your nitro group. So these type of isomers are called as what? Linkage isomers, and the phenomenon is called as linkage isomerism. The third type of your structural isomerism is called as hydrate isomerism. Of course, the name itself we are going to get. So here what is saying means in hydrate isomerism, let me give you an example over here. So CO H2O 6 times of your Cl3 and CO H2O 5 times of Cl H2O Cl2. You can just notice that both the complexes are having the same molecular formula, but they are differing in the number of the water molecules which are acting as the ligands. In the first case, 6 water molecules are acting as the ligands, whereas in the second case, 5 water molecules are acting as the ligands along with the chlorine. Able to understand? So two or more complexes are having the same molecular formula but differ in the mode of the attachment of the water molecule, differ in the number of the water molecules which are acting as the ligands, or which contains different number of water of hydration. So this is called as what? Hydrate isomerism. Coming to the next structural isomerism, it is called as coordinate isomerism. So one thing you have to remember in coordinate isomerism, so it is mainly taking place, so these are the isomerism which is mainly shown in a complexes which is having both your complex cation and a complex anion. That is, the complex should contain both complex cation and complex anion. And it is mainly obtained by interchanging the position of the ligands with respect to that of your complex cation and a complex anion. For example, if we choose CO NH3 6 and CuCN6. Able to understand? So here I have chosen, this is overall is a complex in which one is a complex cation, another is a complex anion. So its isomer, that is the coordinate isomer, is mainly obtained as Cu NH3 6 and CO CN6. You could just notice that both their complexes are having the same molecular formula. But what has happened over here, we are changing the position of the ligands with respect to that of your complex cation and the complex anion. So that type of an isomerism is called as that of your coordinate isomerism. One of the most important things you also remember that, see the coordination number when you're writing for complex cation and complex anion, both should have the same numbers. If, for example, if I choose COEN thrice and here CrCN6, you could just notice that En thrice means what? Though it is thrice means it's a bidentate ligand like that of your oxalate, but oxalate is an anionic bidentate ligand. This is what is a neutral bidentate ligand having two donor atoms. So here also the coordination number will be 6 itself. So coordination number should be same, it cannot change. So when you are writing its coordinate isomers, how will you going to write it? You have to just alternate the positions of your cobalt and the chromium. So you will be getting a Cr, yes, En thrice, and also here you will be getting a CO CN6. So these are called as what? Coordinate isomer. This part is called as coordinate isomers and the phenomenon is called as coordinate isomerism. So these are some of the isomerism types of that of your structural isomerism. So in the next we are going to see with respect to that of your stereo isomerism.